Hi friends, in this session, let's learn an interesting and wonderful problem in different integrations. So, generally, when you look at the question, the idea may not be that much very clear to everyone, but let me explain you so that you can see the hidden things in that. And it's a very, very important concept also. The idea here, the question given here it is they gave a function f of x defined by integral part of x plus square root of fraction part of x plus 1, and they give another function g which is defined integral part plus fraction part whole square minus 1. Now we need to find out the sum of two different integrations. One is over f and another one is over g. Now first before we go to the problem, first let us identify the what is the relation between f and g. Here f of x is defined as integral part of x plus square root of fraction part plus 1. So when you have two functions f and g, and and also it is given that integral 0 to 2 f of x plus 0 to 1 to 3 g of x. If you observe that f of 0 it comes out to be 1, and f of 2 it is comes out to be 3, and these are the limits of this g of x, f of 0 and f of 2. So we can, the moment you observe that the limits of g, integral g will be f of 0 and f of 2, we have a property that integral a to b f of x dx plus integral f of a to f of b f inverse of x dx will be b f of b minus a f of a. The proof of that one is also quite simple. Let me show you in diagram. Suppose the blue colored one is the function f. So between the limits, we are talking about the limits a to b f of x dx. What is this limit a to b f of x dx represents? Here the area bounded by the function with the x-axis between the limits a to b. That means this area. At the same time, what is that integral of what is the area bounded by the same function with respect to y-axis, and that area is this one, and that is same as integral, that will be same as integral my f of a to f of b. Limits are f of a and f of b, and the function is with integral f of a to f of b x dy. What is x? F inverse of y. So indirectly, so that the area with the x-axis gives you integral f of a to b f of x dx, and the area with the y-axis will give you f of a to f of b f inverse of y dy. And when you add these two, so sum of these two will give you area of a blue colored shade part and a yellow colored shade part. That will give you area of the big rectangle, minus area of the small rectangle. Area of the big rectangle is b f of b, because that base length is b, height is also f of b, and that small rectangle will be a f of a. So sum of these two different integrations is equal to b f of b minus a f of a. Okay, now the question arises, the given two functions f and g, are they really one is the inverse of other? Let's look into this. Let's focus on that. F of x equal to integral part of x plus square root of fractional part of x plus 1 is given. Let's call this as y. Then y minus 1 equal to integral part of x plus square root of fractional part of x. When the moment you look at this point, it will give you an idea that since the fractional part is fraction, square root of fractional part is also a fraction. So this integral part of x is the integral part of y minus y. So integral part of y minus y will give you integral part of x. And we have a property from the integration, this minus can be brought it out. So integral part of y minus 1 equal to integral part of x. So if you bring it one to other side, integral part of y equal to integral part of x plus 1. So we got integral part of the inverse function y, and in the same way we want a fractional part. Then what is the fractional part? This itself is the fractional part of y. So how can you write? So what would be the inverse of this function? Will be so this is what x equal to integral part of x plus fractional part of x. So what is the integral part of x? Integral part of x can be written as integral part of y minus 1 from this one, and from the other one, if these two are equal, so a fractional part of x equal to fractional part of y whole square. So this is what x, this is what the inverse function, and that is what given as the g of x here, integral part of x plus fractional part of x whole square minus 1. So f and g are inverses of one another. So the required expression will turns out to be here. This expression will be equal to bf of b minus ef of a, that is 2 into 3, 6. So this is a wonderful and a very important concept of finding that integration of a inverse of a function without actually calculating the inverse function. This concept is so important. Many times it's given in advance IIT JEE advanced examination. So I have explained another wonderful concepts in definite integration questions in my previous video. Please subscribe to and visit our channel for more such interesting and wonderful videos exclusively for JEE Advanced 2025 and 2026. Thank you.